10 billion light-years away, there is a single structure so large that light leaving one end would not reach the other in the entire age of the universe. It's called the Hercules-Corona Borealis Great Wall, and it's nearly 10 times bigger than anything the laws of physics say can exist. We found it hiding in the death flashes of dying stars, scattered across a quarter of the entire sky. More than 10 years later, the people who study it still can't agree on the only question that matters: whether it's really there, or whether the universe just broke its own rules. Because if it's real, the single most important assumption in all of cosmology is wrong. Stay with me. This only gets stranger the closer we look. It started in 2013 with a catalog of gamma-ray bursts, the brightest events in the universe outside the Big Bang itself. A single burst can outshine its entire galaxy for the seconds it lasts, which makes them visible clear across the cosmos. NASA's Swift satellite, in orbit since 2004, catches a few of them every week and pinpoints exactly where they came from. Each burst marks a massive star dying in a distant galaxy. So the way these bursts are scattered across the sky traces the way galaxies are scattered across the universe. And if the universe is truly smooth on the largest scales, the bursts should fall almost evenly. No preferred direction, no clumps, no walls. The Hungarian astronomers István Horváth, John Hackula, and Zsolt Bajali went looking anyway. They divided the sky into cells and counted bursts at fixed distance slices. Most slices looked random, but one slice, at roughly 10 billion light-years away, lit up. In the direction of the constellations Hercules and Corona Borealis, there were far more bursts than chance allows, packed into a region spanning about 125 by 70 degrees, a quarter of everything we can see. The odds of that happening by accident were vanishingly small. So they drew the only conclusion the numbers allowed. The bursts were tracing something real. A concentration of dying stars stretching across nearly 10 billion light-years. A structure. A wall. They named it the Hercules-Corona Borealis Great Wall. The reason the result is interesting and disputed comes from the cosmological principle. Modern cosmology rests on the assumption that the universe is, on sufficiently large scales, homogeneous and isotropic. Homogeneous means that any two large regions look statistically the same. Isotropic means that any direction looks statistically the same. Combined, these assumptions allow the equations of general relativity to be solved analytically for the large-scale expansion of the universe. The principle does not say there are no structures. It says that the largest possible coherent structure is bounded in size. From simulations of the standard cosmological model, lambda CDM, that bound is roughly 1.2 billion light-years. Within that limit, observed structures fit comfortably. The Sloan Great Wall, discovered in 2003, spans about 1.4 billion light-years, already at the edge of the predicted maximum, but explainable with statistical noise in the underlying density field. The Boss Great Wall, found in 2014, is similar. These are at the high end of what can be accommodated. The Hercules-Corona Borealis Great Wall, by contrast, is about 10 billion light-years across. That is nearly an order of magnitude larger than the theoretical maximum. If real, the implications are significant. Either the standard cosmological model is wrong about the maximum allowed structure size, which would require revisiting fundamental assumptions about the early universe and dark matter, or the principle of statistical homogeneity is wrong in a more subtle way. Either outcome would force a revision of how cosmologists model the universe at the largest scales. Both alternatives are uncomfortable. The standard model has been spectacularly successful at matching observations across a wide range of probes: the CMB, baryon acoustic oscillations, supernova distance ladders, galaxy clustering at smaller scales. a 10 billion light-year structure does not fit. Something has to give. This is why the result drew attention. It is also why it has been heavily scrutinized. The skeptical response has been substantive. The Hercules-Corona Borealis Great Wall might not be a structure at all. It might be a statistical artifact of how the analysis was done. Several teams have reanalyzed the Swift GRB catalog with different statistical methods. The conclusions split. One line of criticism focuses on the sampling. The Swift catalog at high redshifts contains a few hundred bursts. Subdividing this small sample into cells and looking for overdensities is prone to look elsewhere effects. The more cells you check, the more likely you are to find an apparent cluster purely by chance. When proper statistical corrections are applied, the significance of the clustering drops substantially. A 2020 paper by Christensen and collaborators applied a more conservative analysis and concluded that the observed clustering was consistent with random fluctuations in a homogeneous distribution. The wall, by their statistics, was not statistically required. Another line of criticism focuses on selection effects. GRB detection sensitivity varies across the sky. Swift has unequal exposure to different regions due to its observing strategy. If the catalog is incomplete in some regions, an apparent overdensity elsewhere could be an instrumental artifact rather than a physical structure. The original Horvath team and others, including Lior Shamir, have pushed back. They argue that the clustering is robust to multiple statistical methods, that the selection effects do not account for the observed pattern, and that the simplest reading of the data is a real structure. The honest assessment in 2025 is that the question is open. The Hercules-Corona Borealis Great Wall may be a genuine structure that violates the cosmological principle. It may be a statistical fluke that proper analysis dissolves. It may also be partially real, a moderate overdensity inflated by sampling bias into an apparent giant. The path to resolution is more data. The Vera Rubin Observatory's planned 10-year survey will increase the catalog of GRB host galaxies by orders of magnitude. Future gamma-ray missions will tighten the redshift distribution of bursts. Either the wall will sharpen into an unambiguous detection, or it will dissolve into the cosmic noise. The interesting thing about the Hercules-Corona Borealis Great Wall is not the certainty either way. It is the precedent. Every time observational cosmology has pushed to larger scales, it has found structure where homogeneity was predicted. The Sloan Great Wall was a surprise. The Boss Great Wall was a surprise. The Hercules-Corona Borealis Great Wall, if real, is the latest in a pattern. The maximum allowed structure size has been slipping upward for 30 years. The cosmological principle has not failed, but the limits it sets have grown softer with each survey. Next video. There is a region of space 330 million light-years across that contains almost nothing. No galaxies, no dust, no anything. We call it the Bootes Void. Its existence is not in dispute. What is in dispute is how it got that empty.